This is a plant test from the same site that I just showed,
Exactly
the soil
so.
site. So if there's something important that you can say, well, we saw this in the soil test we just looked at, but it
Okay.
looks different. This is good because they're from the same property.
That's right. Sample 1 and sample 2, one's for turf grass, one's for trees, and both are on the high level. They have different norms, but because it's available, plants will in fact absorb and translocate to their leaves a significant luxury consumption of nitrogen. Nitrogen is responsible for generating new growth, especially new tissue growth in leaves. So if you apply a high nitrogen fertilizer, especially turf grass, a few days later it's growing like crazy and you're mowing two times a week.
Right.
It's crazy because the plant, it likes it. So what it's going to do is take it because it's available
And then use it.
and use it.
So phosphorus, we touched on that already, but they're showing high levels on the turf side. Is there any negative aspect?
Not really. By the way, I should mention that the tissue samples that were tested for these two samples came from leaves, not roots. We can also do root tissue analysis, which would show probably a higher level than we see on the tissue. But phosphorus is metabolized and transported to leaf tissue, where it's used to help in the transport mechanism throughout the plant, because it's predominantly in the roots, and the phloem and the xylem, which are the transport mechanisms, have heavy amounts of phosphorus in it, and that relates to what we see in the leaf tissue.
Okay. Potassium, anything to look for here?
The labs are very good about giving us norms for these individual species, not varieties, but the species. And for example, on the fescue grass, it's sufficient, slightly below the norm, so we should probably pay attention to that. All plant leaf tissue analyses are kind of a snapshot in time.
Mm-hmm.
And this is, as of that time these leaves were analyzed, this was the nutritional status. Regardless of what the soil is saying, NPK, nitrogen, phosphorus, potassium, if I were to look at this, say, do we need to go out and fertilize this grass? The answer would be a definitive no. Simply because I can look at this test and say it is sufficient in every category there.
Right. Okay. Magnesium.
Gets back to what I said earlier about magnesium in the core of the chlorophyll molecule. It's high to excessive in trees, sufficient in turf. There's no need to add any more. If these were on the low side, then I would say, you know what, maybe if magnesium was the only thing that was low in this, then I would say what I need to do is forget about an NPK fertilizer and look at something that has magnesium in it.
Okay.
And if I do that, then I'm going to get darker green plants that are not going to grow like crazy.
Okay. Calcium. So on this one, it's got high levels on the turf and excessive levels in the trees. How does calcium even get there?
Calcium, interestingly enough, is one of those few elements that a plant must absorb through its roots. Research has shown that you cannot spray on a solution of calcium and have it absorb through the leaves. So all of this came from the pretty good levels, as you remember, in the soil test, at a very good level of calcium. So enough of it is being solubilized because it's only a 7.5 pH. If this were at 8.5 pH, I would expect to see very low levels of calcium in these plants.
So where is the calcium in the soil coming from? How does it get there?
It can come through irrigation water. It can come through the additions of any kind of a calcium electrolyte addition.
Okay.
In my experience, it's impossible to overdose on calcium. The plant will sequester what it doesn't need and then use it later. So the calcium level of these particular plants is in good shape.
Sulfur?
This is interesting. Yeah, high in turf, efficient to low in the trees. One of the reasons for this is because the surface area of turf grass is much greater than it is in trees. Surface area, millions of individual plants. So it has a much more massive root system to mine the soil, which shows up in the high level of sulfur, whereas the tree, by comparison, has a very low mass of root to mine the soil, so we see a much lower level.
Here we're at the dreaded one that we talk about a lot, and I think this one bears a little bit of comment, just even from when we went to this site. This site was one that visually it looked like it was being maintained really well, so this is what I would have thought was a nice property.
Sure.
And the problem that they were having was they're losing trees like crazy, and they don't know why. And their landscapers telling them they have to replace them. When we were there, they were in the process of tearing out and replacing something like 15 trees. When we look at this is one of the few things that it says it has an excess. There's only a couple of places where you have an excess on this whole report, and none of them is it excessive in both the turf and the trees. None of these elements is excessive in both of them except this single element.
Right.
So where is this sodium coming from?
Historically, in my experience, sodium is delivered because it's very soluble in water by the irrigation water. There might be at certain times of year excess sodium delivered by salts used for snow and ice removal, but generally on irrigated landscapes, it's going to come in irrigation water. Even if the irrigation water has sodium in it, but it's not at a high level, the cumulative effect over time, because of the restricted hydraulic conductivity in soils, in other words, it doesn't drain very well, will cause the sodium level to accumulate. And plants will absorb it because sodium is very soluble in water. And once it gets into the systemic part of the plants, whether it's a little 2-inch leaf of grass or a 20-foot tall tree, it gets up into the engine of the tree that creates the chloroplasts and the photosynthetic mechanism. And the genetics say, hey, what is this stuff? What is this sodium? I don't need it. It's toxic. What do I do with it? And plants have this amazing mechanism to sequester this particular element. And usually it's in the edges and especially the tips of the leaves of the plants. It's easy to see on trees, but we mow that off on turf, so we hardly ever see that. But it's there, and that sodium is there. And it can be analyzed quite easily in plant leaf tissue analysis. And what this tells us is if we do not address this problem, and primarily it's being absorbed through the soil, if we do not condition the soil, it will have a detrimental effect on the quality of the plants that are growing in that soil.
Well, in this particular case, we have 0.051 is what the sample has.
Yes.
But the amount that it's supposed to have is 0.002. It shouldn't have more than that.
This would be like saying, I know you would enjoy having one hamburger, but you have to have 25.
Right.
It's going to make you sick.
Right.
So it's going to be incumbent on a landscape manager to look at the data and say, okay, this is something that I need to be aware of and I need to start working on, otherwise it's going to be problematic in the very near future.
Gotcha. Iron, we see that, interestingly, it's high in the turf and low in the trees.
Right. The reason for that is because of the much greater root mass that turf has.
You were mentioning, that's right. Okay.
Same thing.
And is manganese and magnesium, are they related in any way, or is it just...
No, they sound alike, but they're totally different elements and responsible for different metabolic functions inside the plant.
Now, this is a deficient. Could that be affecting the plants in any way if it's deficient?
It can be. Manganese is responsible for regulating metabolic processes in plants. And if you look at this, everything is sufficient to high to excessive, except that one element. So if I were to say to myself, should I be applying anything to the turf on this property, the only thing I can justify is manganese. Now that presents a problem if you have no source for this particular element. The fact of the matter is that manganese is available. It's primarily available through agricultural suppliers. So if a landscape maintenance contractor doesn't have a clue about where to get manganese, tell him to talk to an agricultural supplier because they'll have it.
All right. Boron, what exactly does boron do?
Boron works in conjunction with potassium. It's necessary for plant metabolic functions, which helps in disease suppression, primarily delivered in most parts of the country by irrigation water. This is a sufficient to excessive here. This particular site may, I don't remember what the water analysis shows, may have a water system delivering water that is sufficient or high in boron. The idea is to balance these, certainly with the micronutrients. You want to balance them. So we would like to see either an S or an H in all of these categories rather than all of these peaks and valleys between the different elements. It's called nutritional balancing. It's necessary for good health of individual plant species, especially trees, because they can't respond in the rapid way that turf can.
Okay.
Because of the root mass ratio.
Copper?
Copper is like zinc. You'll know that iron, manganese, copper, zinc, even magnesium, calcium are all metallic. We don't think of them as metals, but they're metallic ions. They also have metabolic functions. These are elements that are required for proper nutrition in a plant so that it can go through and turn that sunlight into carbohydrates.
And zinc does the same thing?
Zinc does the same thing.
Are similar, they're related.
So, for example, if they were deficient, like zinc is deficient in the trees. By the way, I remember these trees. You got low copper, you got low zinc, and even low iron for that matter, but these trees were chlorotic. They were suffering from the damage to the leaves on the perimeters of the leaves
Right.
and the edges, and they couldn't counter effect that even though they had very high nitrogen.
Right.
Okay? If you have high nitrogen levels, why are the leaves chlorotic?
Hmm.
Okay? It's because it doesn't have these component parts like iron to help
Now, I
groom it up.
thought when we were looking at the soil test, it had high amounts of iron in the soil,
Yep.
but it's got low amount in the tree. And
Yep.
that's getting back to some of those things we were talking about where it's not available to the plant because of either the pH or because of other factors. Okay.
Yeah, it comes to the pH. Iron is only really solubilized easily in soil when you get down to a pH of about 4.5,
Okay.
which we hardly ever see.
But for those who care, we have ways around that.
We have our pixie dust.
Okay. All right. Well, that's great. That kind of completes our review of the technical side of what it is that we're looking for and what the different components are and how important they are. So that's it.